Hello and welcome to this YouTube tutorial. In this tutorial I'll be talking about how to sprint your list, a Python list, into pages. Actually, you can use this on your database results, Django project, or a Flask project. Though Django comes with an inbuilt list Paginator, but you can use this to experiment on other projects. Let's get started. Let's say we have a list of animals and we want, and these are 4 animals, and we want to split them into pages, and we want on each page to have 2 items. I will manually do this in Python like this. I will actually manually do it like this. On the first page I would say that animals, and I will access the first page like this, As you see here, I get 2 groups, 2 animals in the first group, and let's say this is our first page, page 1, and we have our second group that starts from 2, up to the last item in the list, which is the 4th item, and we'll print our last item. And this is, let's say this is our second page, which is page 2. Actually, you can check the relationship of these pages if we are actually doing this manually, but you can check the relationship of these pages, and you see in the first page that when our first value was 0, then our second value was 2, and in the last page, when our value was 2, our starting point was 2, our last point was 4. So, and you can check that in the first value it was 0, and in the second page it is 2. So this value increases by 2, which is our which are the results we need for each page, and in our next value, which is the last value, this one multiplied by 2. So we can make this dynamic, and in the first page, if we want to get the first value, like the start value, we can get it by subtracting. Let's say we have our first page, which is the first page, and we want to get the starting point. If you want to make this dynamic, we subtract our page number, this is our page number, we subtract it by 1, and we multiply it by the results on each page. So if we try to print this, our starting point will be, for the first page, our starting point is 0 if it's the first page, and on the next page our starting point is 2, which follows the trend that we see here. So if we want to apply, we can apply this value. We can make this value dynamic. That our starting point is this, and this can be our dynamic value. So we can get this is our first page, and our next page we have 2 pages, and on each page, our next page, when this value is 4, we get cow and goat. So if you want to automate if you want to make this dynamic, the last value, for the last value it multiplies by 2 on the next page. So our stop value can be page number multiplied by results on each page. So we can get the stop value. So our paging is almost there, but say for example we need to know the last, we have like 5 values here. This one could give us something different, like our stop value for the last page. Like here our last page is 3, since we are having 2 items on each page. So our last value would be, our third page will have only 1 value, but if we're trying to check the stop value, it's 6, provided we have 5 items in the list. So we need to solve this. We must add 5 instead of 6. So to solve this, we must get the total number of pages, and we check if it is divisible by the results per each page results, and if it's not divisible by each page and if it leaves a reminder, then we can subtract the reminder from the stop value. To get the total pages, we can calculate the total pages. First off, to calculate the total pages, we need to get the total items. The total items, we divide it by the results we have on each page. We get the total animals the length of the total animal, which is in this case the total animals in the list, which is 5. So if we get the total animals, we get the total pages, we divide the total number, total animals divided by the results we need on each page. This could probably bring about a decimal value, which we don't, it brings about a decimal value which we don't want, because there's no such page called 2.5. So we need to round off this to the nearest number, So for this case, we will need the math library, which comes with a function to seal or round off a decimal value to the nearest number. So we will need this math.seal, and if we round off this, we get 3. And 3 is the next number. So if we try to print this out, we get 3, which is our total pages. The first page takes 2 values, the next page takes 2 values, and the last page takes 1 value. So we need to subtract the remainder. We need to subtract the remainder on the last page, and we remain with only 1 value, which is a problem we have here. We get 6, yet our last value in the list is 5. So we need to make sure that we subtract that remainder from this value, so that we get the correct stop value. So this stop value can change. So it's supposed to change according to the total items we have in the list. So we need to first check if we are on the last page, because this happens on the last page, and we need to check if our last value in the if our total items divided by items on each list is they are divisible. So for this case, we'll check the modulus of the total items. As you know, the modulus returns the remainder of a certain number when it's divided by another number. So if that number does not leave a remainder, the result we get is 0. If it leaves a remainder, the result we get is a value greater than 0. So we can subtract that number. We can subtract that remainder from the items we need. So let's first do that. We check if our page number is the last page, if this page number is equal to the total pages we have, and modulus of the total items in the list is not divisible, leaves a remainder. It gives us a remainder, not a 0. So if our total modulus of our total animals per page, and this one, if it's greater than 0, this means that the remainder that we are getting from the total items in the list is greater than 0. So we need to subtract that remainder from the stop value. So in this case, our stop value will be this subtracted by the remainder. The remainder is total animals and modulus of per each page. So we can decide to put this in a different variable since we are reminder. So our reminder is this one. So if you try to copy this, paste it here. So this is our reminder. We can subtract our remainder from the last stop value of the last page. So this could make our code more accurate, provided the other way around brings the value, but we must make sure that we are having the correct thing. So or else our stop value of the list will be equal to this. So just in case this is an even number, it will stop here, it will not proceed. So if you want to check our stop value right now, I try to print this out, I will get 5 instead of 6. So it means that when the total animals in the list were divided by the items per each page, the remainder was 1, and that 1 was subtracted from the last value that the last top value that we used to access. We are to access the last value in the list. So we subtract that one from the last value of the list. We get a more correct value here, and this is working. So this is the if I try to make this more clean, so this is our page. I can say this is our page. This is our page. This is our page. Yeah. So this is our page, and if I try to change this value around, I still get my results, and I'm having correct results. Sorry, okay, we are getting results. So our code is working fine. So if I try to highlight to get this out of the way, and this, yeah, we're getting results. Let's say for example a user, so we have a problem. Let's say for example a user tries to access a certain page that is out of range. Let's say a user tried to access the 4th page, which is not in the list, which we don't have. This one will return an empty list, which we don't want. So to solve this, we can actually reassign the page. We can say that page is equal to page if the page number is less than the total pages. If our page number is less than the total pages, that means it's below our total number of pages. We use this. We use that page number. It means the correct page. Or else we use, if the user goes out of the range of the pages, we use the total page. Yes, sorry, page number. We reassign this one. Page number. That's it. So we still get our last page, provided the user exits out of the page range. So that's it. Actually, I created a class for this that can help you guys to do things better. And if I check on my second screen, try to get this class can will make things more easier. I actually added all the things and everything is calculated well in this class. You can use this class to do your things. So if we try to test out this class on our list, so if I try to highlight this and I initialize this, we will only need this. If I try to test this class on this list, actually here in the constructor, it tries to initialize. You have to provide the list and the results on each page, and it goes ahead and calculates everything. Then here you get the page by its number, then everything is formatted for you. You get the next page, the previous page, the current page, whether to show previous or next, and the total amount of pages. This can help you. So if I try to say that pagination, P is equal to pagination. So here I try to provide our list of animals and the results on each page. Per page is equal to per page, and we're trying to access this. Save page, don't get page, and we're trying to get the page number. Here we pass the page number. Try to print this out. Actually, it will give you all the data. It will give you the results of that page. Then it will give you the controls, which contain the total pages, whether to show next, or show previous, the total items, then the current page, then the next page, and the previous page. So I hope that, thank you for watching my tutorial, and if this helped you in any way, don't forget to hit the subscribe button, and all the code will be in the description. See you in the next tutorial.